that is called as valence shells electron pair repulsion theory. In short, we call it as VSEPR theory. Very important topic for your board examinations as well as competitive examinations. Okay, so let us first understand a little bit history of this theory. Okay, this theory was proposed by Powell in the year 1940. He proposed this theory. Okay, this theory actually it is totally based on the repulsive forces or repulsive interactions between the bonded atoms or the lone pair of electrons. Between those whatever repulsive forces are acting on those, it is based. Okay, so this theory was proposed by Powell, and in 1957 Gillespie has modified this theory, has improved this theory. Okay, and he suggested basically VSEPR theory. Okay, it is finally improved by Gillespie. It's in the year 1957, and Gillespie says that on the basis of what? On the basis of number of valence electrons present in an atom. Okay, on the basis of number of valence electrons present around the central atoms, the shape of the particular molecules can be suggested. That is what his idea. Okay, and he named that theory as this one, VSEPR theory. What is the full form? Valence shells electron pair repulsion theory. Okay, his idea was that valence electrons are there. Those valence electrons, they undergoes repulsions among each others. Okay, so on the basis of that, he have proposed this theory, valence shells electron pair repulsion theory. And what does this theory states? According to this theory, according to VSEPR theory, the bonded atom in a molecules, okay, the bonded atom in a molecules adapt that particular arrangement in this space. That means the bonded atoms are there. For example, H-O-O. This is called as the bonded atoms. Okay, so the bonded atoms in a molecules adopt that particular arrangement. So this O and this one will be H. So these bonded atoms, it will adopt that arrangement in a space around the central atom in which they are far away from each other. Okay, they will prefer to remain in that structures in which they are far away from each other. So the best structure for them is this one. They are far away from each other, right or not? That is what valence bond theory represents, or that is what VSEPR theory indicates. Okay, so according to VSEPR theory, the bonded atoms in the molecules adopt that particular arrangement, okay, in which they are far away from each other. That one they prefer it. Okay, got it or not? So this is the concept of VSEPR theory. Now we are going to study the postulates. There are 6 or 5 postulates of VSEPR theory. We are going to study one by one the features. Okay. So the first we will write postulates. Very important, these postulates also. Postulate of VSEPR theory. Okay, so basic postulates. Okay, postulates of VSEPR theory. So VSEPR theory postulates number 1. According to VSEPR theory, it is the valence electrons, the electrons which is present in the outermost. It is that electrons which will determine the shape of the molecules. Okay, so we'll write the shape of the molecules. The shape of the molecules. The shape of the molecules depends. The shape of the molecules depends upon the number of valence shells. Depends upon the number of valence cell. Got it? So this is the first postulate. means whatever shapes, which shape the molecules will have, it is totally decided by whom? By the valence shells. That is what the first postulates say. Depends upon the number of valence shells electron pairs. Depends upon the number of valence shells electron pair. Okay, that means the shape of the molecules is totally decided by whom? By the electrons which are present in the outermost shells. Okay, that is the first postulate. Second postulate is what? The second postulate is electron pair in the valence shells tends to repel one another. Okay, the second postulate says electrons pair in the valence shells, okay, in the valence shells tends to repel each other, tends to repel each other. That means those electrons which will be present in the valence shell, for example this one, okay, this is the electrons which is present in the valence shell, so they will try to repel each other, okay or not? That is what it says. That is the second postulate of why they are repelling, because okay, they repel each other because their electron clouds are negatively charged, because their electron clouds are negatively charged. Understood? Because their electron clouds are negatively charged, because the electrons which will be present on the outermost, they will be negatively charged. Okay, so these 2 points is clear. First postulate is the shape of the molecules depends upon the number of valence electrons pair. Second, electron pair in the valence shells tends to repel each other because their electron clouds are negatively charged. So this is the second point. Pause the video and you can take it down. Okay, next, third point we are going to discuss. Okay, the third postulates we are going to discuss. Try to understand properly, dear students. Okay, so the third postulate, it says the electron pair tends to occupy the positions in the space at maximum repulsions. The electron pairs tends to occupy, okay, tends to occupy the position in the space, okay, the electron pair tends to occupy the position in the space at tends to occupy the positions in the space that minimize the repulsions, minimize the repulsions. Okay, so that means what? The electron pairs tends to occupy the position in the space that tends to minimize the repulsions. Means what? Those electron pair, they will occupy such a positions that the repulsions between them will be minimum. Got it or not? So such positions they want to occupy. Okay, so that is what third postulate tells us. Fourth, the valence shells is taken as a shared as a sphere with electron pair load. Okay, this one is okay, no problem. The fourth point, okay, the fourth point, the repulsions in the repulsive interactions, the repulsive interactions, okay, the repulsive interactions decreases in the order. This order was asked in exams, okay, so try to learn it properly. Okay, the repulsive interactions decreases in the order lone pair, lone pair, lone pair, lone pair. Okay, lone pair, they will have maximum repulsions. Here the repulsion is maximum. Maximum repulsions. Then the next comes lone pair, bond pair repulsions. Lone pair, bond pair repulsions. Okay. Then at the last it is bond pair repulsions. Okay. Bond pair repulsions. Got it? Okay, so the repulsive interaction decreases in the order lone pair, they have maximum repulsions. Lone pair, bond pair, it will have little less repulsions, and bond pair will have minimum repulsion. For example, this is bond pair and this is bond pair. Okay, this is one bond, this is one bond, so the repulsions between the bond will be less. The repulsions between the, suppose, bond and the lone pair, it will be little more, and the repulsions here between the lone pair and the lone pair, it will be maximum. Got it? So this order is very, very important. Okay, so you should remember it. Now next I am going to give you the last postulates. Okay, so the last postulates for repulsive, okay, the repulsive forces decreases the repulsive forces decreases sharply with the repulsive force decreases sharply with increase in angle between the electron pair. Decreases sharply with increase in angle between the electron pair. So this is the fifth postulate. So it used to come for 3 marks, dear students, so you have to study properly. Okay, repulsive force decreases sharply with the increase in angles between the electron pairs. So as suppose here angle is less, so repulsive force will be more. Here angle is increased, so repulsive force will be sharply coming down, it will decrease. Got it or not? With increase in bond angle. So these are the 5 postulates, you should remember it. Okay, so pause the video and take it down. Okay, so now we are going to do very important things. Okay, try to understand. If you learn this table properly, if you have understood, then rest of the things will be very easy for you. Okay, so shape of the molecules on the basis of VSEPR theory. Okay, so this table you try to understand properly. The first column is number of electron pair around the central atoms. How many electron pairs are there around the central atoms? That one we will write here. Arrangement of the electron pair, how we have arranged those electron pair. Then by arranging in that manner, what geometry we will get, what shape we will get, and what will be the bond angle, and what are the examples. Okay, we will be writing it here. So first, the number of electron pair around the central atoms, we are assuming it to be, pair means this one and this is 2. Okay, 2 electron pairs. Okay, so number of electron pair is 2. So the arrangement of the electron pair will be like this. One electron pair will be here, one electron pair will be here. Got it? In the middle we are writing it as A. So this will be the arrangement, and here it will be 180 degree bond angle. Okay, got it? Okay, now a molecular geometry, how it will be, you will be writing here A, here it is B, here it will be B, and here bond angle will be how much? 180 degree. Okay, got it? So what is the bond angle here? Bond angle is 180 degree. What will be the example for this kind of structures? Which molecules will have? BeF2, BeF2, then BeCl2, BeCl2, BeH2, okay, and another one is ZnCl2. So these are the compounds which has this structure, and the name of the structure is called as what? The molecular geometry, we call it as linear. Okay, this is linear structure. Okay, now the number of electron pair around the central atom is suppose 3. Then how will the electron be arranged? 1, 2, 3. 1, 2, 3. Got it? This way we will be arranging. And what will be the angle here? The angle here, it will be 120 degree. Got it? So molecules, how will be arranging the molecule? Molecules will be arranged in this way. A, here it will be B, here it will be B, here it will be B. So the arrangement will be this way. This bond angle is 120 degree. So here bond angle, we'll write it how much? 120 degree. And what will be the shape of this? What will be the name of this shape? It is called as trigonal planar. And the example for trigonal planar is BF3AlCl3. So example is BF3AlCl3. So whenever you are asked in the exam on the basis of VSEPR, draw the shape of AlCl3. So this is the shape of AlCl3. How you will be drawing? F, here you will be placing F, and here it will be done. Okay. A is the surrounding atom, B is the surrounding atom, A will be the central atom. Okay. Fine. The fourth one, if the number of valence electron around the central atom is 4. If the number of valence electron pair, these are the pair 1, 2, 3. So number of valence electron pair around the central atom is 4. Then how will be the arrangement? So you see, the arrangement will be this way. 1, here is the valence shells, here is the valence shells, here is the valence shells, here is the valence shells. So 1, 2, 3, 4. So it will be arranged this way. Okay, so here we will be calling here the angle will be 109.5 degree, 109.5 degree, and here the molecular geometry will be like this. Here A will be there, here B, B, and here it will be B. So we will join it this way. So here the bond angle is 120 degree, and the geometry we call it as what? Tetrahedral. Tetrahedral, tetrahedral. And what is the bond angle here? The bond angle here, it will be 109.5 degree. So 109.5 degree. All the tetrahedral structure, they have bond angle 109.5 degree. And example for this is CH4 SiH4. Example is CH4 SiH4. Okay, then SiH4 SiF4, SiF4, and NH4 positive. So this all these compounds will have tetrahedral geometry. Okay, dear students, I hope you are understanding. Okay, now 4 we have done, 5, 6, 7 is there. Let's draw it quickly. Okay, so you can pause the video and take down the table. Okay, hope you are understanding. It is not that difficult. Okay, once you will understand these structures, on the basis of this only we will be drawing the others. Okay, so it is not that difficult. Try to learn it properly. Okay, if you learn it, it will help you in class 12. Even in the board examinations, competitive exams, you get a questions from here. Okay, you might be thinking that sir is telling every topic competitive exam is coming, their student is coming, that's why I'm telling you. Okay, so 5. Now the number of electron pair around the central atom is 5. Okay, so if the number of electron pair around the central atom is 5, then how will be the arrangement? The arrangement will be in this manner. This is how the electrons will be arranged here. Okay, this is how we will be arranging the electrons. Okay, and here there are two angles are there. Okay, axials and equatorials. Okay, so axials angles will be here. This is called as axial angle. Okay, so axial angle will be here, two axial angle will be there. Axial angle. Okay, and equatorial, here it will be, there will be 3 equatorial angle will be there. Okay, equatorial angle, here it will be 3, 1, 2, 3 angles will be there, as which will be called as equatorial. Okay, so how will be the molecular geometry? You see here it will be A, B, 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 okay, so this is the things, and here this is equatorial angle, this sorry, axial, and this will be the equatorial angles. Okay, so this geometry is called as pentagonal bipyramidal, bipyramidal, pentagonal bipyramidal. Here angle is 90 degree and here it will be 120 degree. Got it? So here we will be writing it. Okay, here we will be writing it. Bone angle is how much? Axial. How many angles are there? 2 angles, which is equals to 90 degree. And equatorial, how many angles are there? 3 angles. Each angle is equals to 120 degree. Okay, so in pentagonal bipyramidal, axial there is 2 angle, equatorial 3 angle, axial 90 degree, equatorial 120 degree. And what are the example? PF3, SiC, PF5, SiCl5. So these are the examples of pentagonal. Okay, now 6th one we are going to do. If they have the 6th lone pair of electron around the central atom, then how will be the arrangement? 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4. Okay, the arrangement will be somewhat like this. Electron pair, we will be arranging it in this manner. Okay, this will be the arrangement of electrons. Okay, got it? Okay, so here we'll do the molecular geometry here. So molecular geometry will be A, B, 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 and this one will be, like this. So this shape is called as what? Octahedral. octahedral, and geometry here will be 90 degree. Okay, the bone angle here it will be 90 degree, and the example is SF6 TEF6. Example is SF6 TEF6. So in the exam, sometimes in the competitive exams and all, they ask which one is the correct shape of SF6, which one is the correct geometry of SF6, right? Octahedral. Okay, got it, dear students? So hope you have taken down your understanding. Okay. Okay, then pause the video and take down. Next we are going to the last number of electron pair around the central atom, that is 7. Okay, and this one properly learn it, dear students. Very important, this topic. Okay, okay. Here the number of electron pair around the central atom is 7. So in this case, how the electron pair will be arranged, let us see. So here this arrangement will be done like this. Sorry. One, two, three, four, 5. 5 electron pair is already there. Now so 1 will be here, 6, 1, it will be like this. Okay, so this is the arrangement of electron pair. Okay, for 7 number of electrons, 7 lone pair of electrons. So geometrical structure will be how? Geometrical structure will be this way. Okay, the geometrical structures will be drawing it in this way. So here it is A. So this one it will be B. Here it will be B, 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 B. So see 1, 2, 3, 4, 5, 6, and here 1 will be there downside B. So 7 are there. And what is the shape of this? This shape is called as what? Oh sorry, the previous one I have made a mistake. It is called as trigonal bipyramidal. Okay, this one it will be called as what? Pentagonal pyramidal, pyramidal, pentagonal bipyramidal. This is the structure. Once it was asked in the NEET exam, what does IF7, which type of structure does IF7 has? So pentagonal bipyramidal, 4 marks. Okay, so here there will be axials and equatorial will be there. So here axials it will be 90 degree, and this one it will be equatorial 90 degree, and this one it will be equatorial 72 degree. Okay, so here we have two angles, 90 degree and 72 degree, and the example is IF7. Okay, so this is IF7. One, dear students, I made a mistake. One, that is 5-1. So that fifth one I have drawn the structure this way. Okay, all of you please rectify it. Sorry. B, 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 here it is A. This way it is coming, here it is B, and here it is B. This is not called, I have written there pentagonal, it should be trigonal. Okay, trigonal bipyramidal. Okay, by pyramidal, bipyramidal. Okay, so the shape name is trigonal bipyramidal. I have given you by mistake pentagonal pyramidal. Okay, so it should be trigonal bipyramidal. Please rectify it. So dear students, we have completed the VSEPR theory. The structures we have completed. Now in the next class we will be seeing how, if the all are bonded pair, so we have done the structures. Now if along with the bond pair there is a lone pair also, then how the structures will be done, that one we will discuss it. And after that we will be discussing MOT, and then we will be discussing the hybridization, and with that this chapter will be concluded. Two more very important topics are there, this topic and hybridizations, and then MOT. These are all 5-mark topics. Okay, and out of these three, one confirm 99 or 100% it is going to come in your examinations. So that's why, dear students, you should study properly these three topics. Okay, got it? So with this I will wind up my videos, and definitely if you have liked the videos, if you have learned something with these videos, please don't hesitate to share with your friends, and don't hesitate to subscribe the channel if you are new to the channel, and click the bell icon so that you will get a notifications when the new videos is uploaded. Thank you, dear students.